Knowing about different concepts and features is great, but software development is a craft. You need to be able to apply your knowledge to different situations and combine multiple features to a working solution. That's what the monthly coding problems in the Persistence Hub are for. In each of them, I show you how I solve a common task or problem and explain the reasons for my decisions. For the next few days, everyone who joins the Persistence Hub gets all 11 coding problems of 2024 as a free bonus. You can find the link to join the Persistence Hub and claim your bonus in the video description at the top right corner. And now let's jump to the coding problem video of February 2024, in which I discussed different options to track the creation and last modification date of an entity. Hey, and welcome to this month's coding problem. The problem and the solutions I want to show you are quite common in many enterprise applications because there developers get asked to track when was a record created and when was it last modified. And you can of course implement that in various different ways. And here I want to show you 3 different solutions to it and explain when I prefer which of them. So let's dive right in. The test case that we will use in all 3 examples are quite simple. You can find this entire project with the problem project and my 3 different solutions on GitHub in the Persistence Hub GitHub organization. So what does my test case do? It takes a simple chess tournament entity, and I will show you that entity in a minute, and persists it. After that, it checks that the creation date and last mod date fields are set, and well, that this is that the creation date is close to now, and that the creation and last modified date are almost the same. And then we have a second transaction that fixes a spelling error in the tournament name. And after that, I expect that the last modification date is clearly after the creation date of the tournament. So how does the chess tournament entity look like? You can see it here. It's quite simple. It has a generated primary key, a name, start and end date, and a version attribute for optimistic logging. If you're not familiar with the version annotation, I recommend you take a look at the optimistic and pessimistic logging lectures in the Hibernate performance tuning course. The 2 fields relevant for this coding problem are the last mod date and the creation date. And well, that one obviously tracks the timestamp when this specific chess tournament object was persisted, and this one the time when it was last modified. And in this case, I've just 2 attributes. They are not annotated with anything up here. And as you can see here, there's nothing on the chess tournament entity that might tell Hibernate to handle these 2 attributes in any specific way. So when I run this first test case, then you can see that it fails here with an assertion error because it obviously doesn't get set. So how do we fix that? Well, one option would of course be to go into our business code and call a setter method for the creation date and the last modification date, and then make sure that we call the set last mod date method every time we change something on the entity object. But that's pretty error prone. Sooner or later we will forget changing the last mod date, and that's an option I personally don't like. So let's take a look at 2 other options. Well, so here we have the same test case as before. And well, let me close the other 2. And yeah. So the easiest option is to add update timestamp annotation to the last mod date field and a creation timestamp to the creation date, and let Hibernate actually just provide the timestamps for this. So You can see here, these are annotations from the org Hibernate annotations package. That one as well. And when I now run the test case again, you can see that Hibernate automatically provided the timestamps for the insert and update operation. And here the creation date gets set as the first bind parameter on the insert statement to this timestamp, and the last mod date as the third. You can see it's a slightly different timestamp than the one that was used for the creation date. And the reason for that is quite simple, that the two annotations that I added here are handled independently of each other. So you could also decide to just add a creation timestamp annotation to one of the fields or an update timestamp, and that would be good enough for that specific field. They don't have to be used together. We also see that during the update operation, the creation timestamp gets set again, and that is the same time we had up here. And the reason for that is quite simply that Hibernate generates a create or an insert, an update, and a delete statement for every entity class when deploying the persistence layer. And it then just reuses these statements every time you modify an entity. And from a performance point of view, that is great. The downside of that is that every update statement sets all fields of that entity object. And that can look a little bit strange if you are using some trigger-based auditing mechanism or something similar. And you should also have that in mind when you are implementing any on-change trigger on your database. Hibernate will always set all fields unless you annotate the entity class with a dynamic update annotation, which then forces Hibernate to figure out which field was changed and then generate a specific update statement for it. Yeah, from a performance point of view, I recommend you just stick to the default. Okay, so what did we see here? We saw that the creation and the last mod date were now set, and that the only thing that we had to do was add an update timestamp annotation and a creation timestamp annotation. And well, if that was the only thing you had to do, then you can use these annotations and you're done. If you don't want to rely on a Hibernate specific feature, so just use something that's defined by the JPA standard, or if you want to do more, like make sure that the creation date and the last mod date are exactly the same for the insert operation, or if you want to track which user changed or persisted the record, then you have to use a different approach. In that case, you go to the entity class. This is a simple copy of the problem project. And here you could use a lifecycle callback. Let's call this method prepersist and annotate it with prepersist. This annotation tells Hibernate that the method on which I put it is a lifecycle callback and that it is supposed to be triggered before executing the insert statement. Or to be more precise, Hibernate will call the method annotated with prepersist when you call the persist method on the entity manager with a chess tournament object. So immediately here. And within this method, I can now do whatever I want as long as I'm only working with the current entity object. So I can use that to say this creation date is local date time now. And let's say we want to make sure that the last mod data and the creation data are exactly the same when persisting a new entity. Then we can set the creation date to the last modification date. No, the other way around, the last modification date to the creation date. Okay, that is that are the operations we need to perform before persisting a new record. We, of course, also need to handle the update statement, which, from a business logic point of view, is much more important because that can happen in a lot more places in our business code than the creation and persist operation of a new object. So let's call this pre-update, and you always see I added a pre-update annotation to it, and that tells Hibernate that this method has to be called before the update statement gets executed. And this time I just want to set the last mod date to the new timestamp. So let's run this. And we see here that, well, first of all, the test case passed. And it checks that creation date is not null, last mod date is not null, and creation date is supposed to be close to now when executing this test case, and the last mod date is supposed to be close to the creation date when we persist the new record, and after the update, last mod date is supposed to be not null and clearly after the creation date. So let's quickly check the log output. Here we see again, creation date is the first, last mod date is the third parameter of the insert operation. And this time we are using exactly the same timestamp because you saw it in the implementation. I get the current date time once for the creation date, and then I set the same value to the last mod date. And down here we have a last mod date that is clearly after the creation date. Okay, so here we implemented our own methods and we can basically do whatever we want here. That means we could also set other fields or, for example, get the current user from our authentication component and set it as the creation user and last mod user. One common mistake I see in many projects is that developers are not using the pre-lifecycle callbacks, so not the pre-persist and not the pre-update. Instead, they use the post-persist. And that is not a good idea. Let me show you why. When I now run the test case again, then we have the problem that the timestamps are not set when persisting the entity object. And the reason for that is that in the test case up here, we create a new entity object. We call the persist method, and the persist itself doesn't trigger the insert operation, but the post-persist lifecycle callback is triggered after the execution of the insert statement. So the timing is critical. When executing the commit of the transaction, Hibernate performs a dirty check on all objects in the current lifecycle, in the current persistence context or in the first level cache, and finds this object that we persisted here. It executes the insert statement and thinks that it is done now. But after executing the insert statement, our post-persist method changed the creation date and the last mod date fields. So now, and we saw that down here, these fields are set on the entity, but Hibernate already performed the last dirty check and thinks that it found all objects that had to be persisted or modified in the database. And that's no longer the case. And due to that, we should be very careful with using post-lifecycle callbacks to change anything on any entity object. As you saw, if this post lifecycle callback gets triggered by the commit, then Hibernate will most likely not detect that there was any modification done in this post callback, and due to that, the change will not be persisted. The same is the case if you modify any other entity object within these callback methods. So officially, you're not allowed to do that. And please follow that rule and don't change anything. Otherwise, you will run into the same issue we just saw with the post persist. So let's say we have a chess game entity that is or a chess player that is associated to this chess tournament, and we would here in this pre-persist traverse the association to the chess players and change something there. Then Hibernate's dirty check might have already checked all chess player entity objects for modifications before triggering the pre-persist callback, and our change here will then go undetected if Hibernate triggers this lifecycle callback during the commit operation. Okay, so lifecycle callbacks are great if you want to implement a specific callback for an entity object, or for all objects of one entity class. But stuff like this, so the tracking of timestamps when something was modified or created, are quite often supposed to be applied to many different entity classes. And you have different ways to do that. One option would, of course, be to introduce a mapped superclass to the chess tournament and to all other entities and move the lifecycle callback there. So lifecycle callbacks on superclasses get always triggered also for our subclasses. But I don't like introducing a mapped superclass just to handle something like this. Inheritance mappings are, at least in theory, supposed to be used on on classes that form a real inheritance hierarchy. So where in the best case, your user knows what you're talking about when you're talking about the superclass, mentioning it as a concept. And a base entity that just provides lifecycle callbacks is clearly not that, right? So my recommendation there is that you use an entity listener to handle the lifecycle callbacks. So let's close this and introduce a new interface. Let's call it a tracked entity. And that is an interface, and that has a method set last modification or last mod date, local date time, mod date, and creation date. So these are the two methods that our chess tournament already implements. So tracked entity. Okay, and then we can introduce an entity listener. Let's call it track modification listener. And that is a simple Java class. So nothing special here. And now we can implement the same methods that we implemented a minute ago on the chess tournament entity, and that is a tracked entity. And here we can then call the entity set creation date, local date time now, entity set last mod date, local date time now, and add a pre-persist annotation to it. And let's call this, I use the pre-update callback and call the method pre-update. And then we just need the last mod date. Okay. So now I added an interface that we can add to all our entity classes for which we want to track the modification data and the creation date. And I added a listener definition, so simple Java class with two lifecycle callback methods, pre-update and pre-persist. And the last thing I now have to do is I have to add the entity listener to the chess tournament class. You can do that with the entity listeners annotations. And here we just reference the track modification listener class. And when we now run the test case, we see that the test case passed. So the two listeners, you know what, let's quickly add that here. And that is the track modification listener pre-persist, and pre-update. And run the same test case again, and now we should see in the log output that there our listener got called before the update statement for the chess tournament. Entity got called, and the same up here for the persist operation. So that is the third option that we have to implement the tracking of last modification date and creation date, and this time based on an entity listener. So I showed you three different ways. The first one was the simplest one. And here we just add a creation timestamp and an updates timestamp annotation to the two fields of our chess tournament entity and of any other entities for which we want to track this. And this is my preferred approach if I just need to track the timestamps and if I'm sure that I can rely on Hibernate proprietary features. That means when I know that we will not deploy this persistence layer in some stack that uses Eclipse Link, for example, instead of Hibernate, and if it's rather unlikely that we will migrate our application from Hibernate to Eclipse Link in the foreseeable future. If I need a little bit more flexibility, then I usually prefer the listener-based approach, this one here, because by introducing the interface and the listener, I can provide a solution that I can easily add for various different entity classes. And that is usually required in these cases. So as soon as I need flexibility, I add the interface, I add the listener, and then just register the listener here. And if I have a new entity for which I, for example, also have to track the two dates and maybe the user and do something else, then I just add an entity listener up here. You could also add multiple listeners. So this is an array, just provide a comma-separated list of listener classes, and Hibernate will trigger the annotated methods for each of them. The second option that I showed you, the pre-persistent, the pre-update lifecycle callbacks on an entity object, they are fine. There's no real reason to not use them. The lifecycle callbacks are supposed to be used and were designed to be used in these kind of situations. The only reason I rarely use this approach is that it would require me to add a pre-persist and a pre-update method to every class for which I want to track these dates. And let's be honest, I'm just too lazy for that. I prefer to put that stuff then into an entity listener and just add the listener and don't worry about the different pre-update and pre-persist method implementations. If you have something like a base entity, where you could add these lifecycle callbacks, then adding these methods to that base entity, which is usually a mapped superclass, then that is a great idea. If you're not familiar with mapped superclass, please take a look at the inheritance mapping lecture in the advanced Hibernate course. There I'm explaining the different ways to map inheritance with Hibernate, and yeah, mapped superclass is one of them, usually used for these purely technical superclasses where we just want to share a few mappings. Okay, so that's it for now. As you saw, there are different ways to implement something like this, so the tracking of creation and update timestamps, but especially the second and third approach that I showed you today are pretty generic. You could use them for all kinds of operations or initialization of attributes whenever you persist or update a record. When you look at the lecture about lifecycle callbacks and entity listeners in the advanced Hibernate course, you will see that there are a bunch of other lifecycle callbacks as well. So 7 in total: before and after insert, before and after update, before and after delete, and after loading of entities. And yeah, if you're not familiar with that, I recommend you take a look at that as well. That was the coding problem video of February 2024. If you joined the Persistence Hub until Friday, you get all 11 coding problems of 2024 as a free bonus. And you also get access to my premium video courses about Hibernate and Spring Data JPA, monthly expert sessions, Java persistence news, and more. So go to thorbenjanssen.com/join Persistence Hub and join the Persistence Hub.